Today we're going to delve into more about the notion of amplitude, frequency, and period. Three things we talked a little bit about yesterday on the video. So the warm-up is actually part of the notes today. So if you were able to print out the notes, you can try this warm-up section up at the top. This is it right here. So I just want you to graph sine and cosine between 0 and 2 pi, so that basic graph that you saw yesterday, and then state amplitude, frequency, period, phase shift, and midline. If you want to get out your notes from yesterday, that might help. If you don't have this printed out, if you want to just do this on the separate sheet of paper, again, this is the first part of the notes anyways, go for it. So take a couple minutes and do that. All right, if you're ready to see if your answers are right, here we go. So for the sine graph, sine always starts its cycle at 0. So it starts at 0. At pi over 2, you'd be up to 1. Pi goes back to 0. 3 pi over 2 is -1. 2 pi is back to 0. And remember, it's got to be a wavy graph. I'm going to put arrows because remember, it does go on and on forever in both directions. Cosine starts up at 1, goes to 0, gets to -1, back to 0, and +1. And again, has to be wavy. 1's the top, so it's going to start bending down after that again. Put arrows. Now I guess, okay, technically since this says over the interval from 0 to 2 pi, normally on the regions we wouldn't do arrows there. Okay, so you can decide if you want to keep them on there or if you want to keep them there. But remember that arrows should be there if it's a normal graph because it does go on and on forever. Okay, now for both of them, these values are the same. Amplitude is a couple ways to think about it. One way you'd want to think about it is max minus min divided by 2. The maximum value in both graphs is 1. The minimum is -1, all divided by 2. So that's 2 over 2. That's why the amplitude is 1. Remember what frequency meant? Frequency was number of cycles between 0 and 2 pi. And both of them have one complete cycle. Hill and a valley, up, down, up. So the frequencies on both are 1. Remember what period means? That's the length of one cycle. And obviously we graphed one cycle and they both took a distance of 2 pi on the x-axis to get there. The period for both of them is 2 pi. Phase shift is just a fancy word for the horizontal translation. If it goes left or right at all. These don't go left and right at all. They both start their phases at x equals 0. So the phase shift is 0. And then the midline is the vertical translation. And you might have noticed on the homework last night, I don't think anyone asked me about it, but sometimes they call this the wrap line. It's the same thing. Wrap line just means the graph wraps above and below it, kind of. But the midline kind of tells you what it does too. It splits the graph in half horizontally. So the midline here, a lot of you wrote 0 on the homework, and it technically isn't 0. It's y equals 0 because it's a line. So you want an equation of that horizontal line. So it does affect the vertical translation. So there's a +0. That's why the number here is 0. But always make sure you write y equals. Okay, so today we're going to look more specifically at the equations. And we're going to look at the effects of A and B in these equations. So it says using your graphing calculator, sketch windows of each of the following between 0 and 2 pi. It's a good idea for you to get practice sketching these. You want to be in radian mode. And the reason I know I want to be in radian mode is because my window is getting set up between 0 and 2 pi. So make sure you're in radian mode. And then with the trig graphs, if you can set up the window ahead of time, that will help you too. So grab your calculator if you don't have it. Make sure your mode is radian. Mine already is. But for the window, if you look at these graphs, we want to go from 0 to 2 pi. So x min is 0. Y max, type in 2 pi. When you do that, you'll see a big decimal just pop up. That is 2 pi. The y min, it looks like we're going down to -4 and up to 4. So do that too. And then we're just going to start graphing these. Okay, so if I do y equals, so there's a log graph in there. If I put 2 sine of x, and then just hit graph. Sine graph, we know it starts at 0. This is going to be pi, and this is going to be 2 pi. If you want the lines on the x-axis to match up too, what you can do, in window, is you can make x scale. These are going by pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So if you want to write the scale to be pi over 2, the only advantage to that would be when you graph it, now you'll be able to see where these points line up exactly. So it's 1, 0, -1, and back to 0. Okay, so the big difference, what happened from here when you compare it to the original sine graph? Instead of going up to 1, it's going up to 2. And it's going down to -2. So the first graph, it's got cut off a little bit over here. Not sure if it did on yours too. Starts at 0, goes up 2, and it's a little bit hard to see here. I think this is 2. This is 0, down to -2, back up to 2. Okay. Next one's -3 sine of x. So I'm going to take this out and instead put in -3 sine of x. This goes down to -3 first, and then it comes up to +3 second. So start maybe thinking about what's happening. Why is it going up and down to 3, and why is this going in the valley first instead of the hill first like normal? So it started at 0, pi over 2 is at -3, back to 0, +3, back to 0. There you go. Okay, 1/2 cosine of x. So now I'm doing a cosine graph instead. So 1/2 cosine of x. So cosine, remember, starts up, but it doesn't start all the way up at 1 this time. It only starts up at 1/2. And it only goes down to -1/2. So it's kind of like a squished cosine graph. So it starts at 1/2, 0, -1/2, 0, +1/2. So it's a really narrow graph, like that. Okay, and then the last one, is -4 cosine of x. So -4 starts all the way at the bottom, goes all the way to the top, then comes all the way back to the bottom. So even though it's cosine, cosine normally starts up at 1, this starts down at -1. So as I graph this, think about how do you know, or why, just from looking at the equation, would it start down instead of up? Okay, now in all of these I want to come up with the amplitude and the range. Now for amplitude, I know you might be able to know it just by looking at it, but I'm doing this for a reason. I'm going to keep doing max minus min divided by 2. So what's the max of this first red graph here? The max is 2. So 2 minus the minimum of -2, all divided by 2. 2 plus 2 is 4 divided by 2. So this amplitude is 2. For the blue graph, what's the max? The max is still 3, even though the min happens first. The min is -3, so 3 minus -3 divided by 2 That's 6 divided by 2, so that has an amplitude of 3. Green graph, the maximum was 1/2 or 0.5 minus negative 0.5, all divided by 2. So 0.5 plus 0.5 would end up being 1 over 2, so it has an amplitude of 1/2. And the purple graph has a max of 4 minus a min of negative 4, all divided by 2, so 8 over 2, amplitude is 4. Okay, so you can tell that just by how high or low it goes. The reason I do it with max minus min divided by 2 every time is because right now the graphs are all kind of centered along the x-axis. But once those start shifting up and down, it's going to be harder to tell what the amplitude is, so you're going to always want to use that formula. What's the range of all these graphs? What's the low to high? For the red graph, it's -2 to 2, with brackets always, because it does hit those values. The blue graph is -3 to 3. The green graph would be -1/2 to 1/2. And the purple graph would be -4 to 4. So the thing to notice is that value out front is basically telling you the amplitude. So the conclusion is that the value of A, again, A is referring to that number out front of the graph, it's the vertical stretch, it affects the height of the graph. And the absolute value of A will always give you the amplitude. You can see that all these amplitudes were positive, even though sometimes A was negative, like in B and D. And that's because, again, the amplitude is always high minus low divided by 2. So it's just the height that it's going from the midline. So it's always absolute value. But if it is negative, what happens? What does the negative out front normally do to a graph? It reflects it. So make a note that -A reflects an x-axis. And the negative is what causes that reflecting. And again, this is just a fancy word for vertical translation or vertical dilation, vertical stretch or shrink. Now, does A affect the range? Yes, because originally the range was -1 to 1. All of these get affected by what that vertical stretch was, and it makes sense. If you're stretching vertically, you're affecting your up and down. So make a note for all the ranges that A also affects range. Okay, so I think you have a good idea of what A does. Let's talk about B. So before I flip the page, remember that B was that number inside multiplied by x. So use your graphing calculator to sketch these graphs from 0 to 2 pi. Okay, here we go. So we're going to start with sine of 2x. Sine of 2x only goes up to 1 and down to -1, but look what happens. That's one cycle right there. Now here's another cycle. So there's 2 complete cycles between 0 and 2 pi. So I know that when I graph this, I have to end one cycle at pi. Oops, didn't realize that my graph got cut off again. There's my graph. So I'm starting still at 0 because it's a sine graph, but I'm ending at pi. So I have to go all the way up and come all the way back by the time I get to pi. Then that happens again. All the way up, all the way down, and I'm back. One cycle is right here, because one cycle of sine is up, down, and back. So frequency, remember, we talked about it's the number of cycles between 0 and 2 pi. So this one has a frequency of 2. The period is the length of one cycle, and we said that one cycle had a length of pi. All right, sine 1/2 x. Let's look at that one. Here's the graph. Sine of 1/2 x, it still gets up to 1, but it's only got the hill part. If it kept going, you'd see the valley part after that. So this starts at 0. By the time it gets to pi, it's at 1. 2 pi, it's back to 0. It's got just the up part of the sine graph. So what do you think the frequency would be? The number of cycles between 0 and 2 pi. Right, there's not even a full cycle here. So this is just, there's half a cycle. So what would the period be? How long would one full cycle be if I went up and down and back? It'd actually be 4 pi, right? So I'm just going to write one cycle goes to 4 pi. So that's the period, because you got to get that full up and down. All right, cosine of pi over 4, or sorry, cosine of 4x. Before I draw it, what do you think the frequency is going to be? How many complete cycles of cosine are you going to see between 0 and 2 pi? Let's see if your guess is right. There's 1 cycle, 2 cycles, 3 cycles, 4 cycles. So the frequency is 4. It starts up at 1 because it's cosine. By the time it's at pi over 2, it's back to 1. So right in the middle here, it'd be at -1. And the same thing happens between pi over 2 and pi. And then pi and 3 pi over 2. And then 3 pi over 2 and 2 pi. So there's 4 complete cycles. What would the period be? Well, here's the length of one cycle. So that's pi over 2. It only takes a distance of pi over 2 to make one full cycle. All right, last one. If I do cosine of 3x, what do you think the frequency is going to be? Frequency is, there's 1 cycle, there's 2 cycles, there's 3 cycles. So the frequency is 3. This one's a little bit hard to draw just because it doesn't end in a nice spot. As you can see from the graph, the first cycle ended a little bit after that pi over 2 spot. And there's one in the middle, one at the end. So if you kind of like divide this up into thirds, it's not perfect, but there's 1 cycle, there's 2 cycles, there's 3 cycles. It'll look something like that. Any idea what the period would be? Well, let's talk about period for a second. Again, if period is the length of one cycle, how am I getting these values? I can look at them on the graph, usually. This one's a little bit harder to tell because it doesn't land in a nice spot. This is definitely 1 cycle. I'm not exactly sure what that spot is just looking at the graph. So think about what you're doing. You're taking a distance of 2 pi, where you're graphing everything, and you're dividing it by how many cycles there were. So if I have that distance of 2 pi, and I divide it by 2 cycles, that's how I get that my period is pi here. I can even do it with this blue one. If I take 2 pi, but divide it by half a cycle, it's a complex fraction, so if I multiply top and bottom by 2, we get 4 pi. Here, if I take my 2 pi and divide it up into 4 cycles, we get pi over 2. So what do you think the period is going to be for the purple graph? Just take 2 pi, divide it by 3 cycles, so it's 2 pi over 3, which is 120 degrees. Okay. Lastly, the range. What's the range of this red graph? Goes down to -1, up to 1. How about the blue graph? Now, technically on the graph, it's 0 to 1, but if I kept going forever, what would it be? Yeah, we get down to -1 eventually. So -1 to 1 again. Green graph, still -1 to 1. And purple graph, still -1 to 1. So the thing to note from all of that is that B value, although it affects how many cycles there are and the length of the cycles, does not affect the range. And that makes sense, because if you picture like an accordion, you're just like pulling an accordion out and pushing it back together with all of these. So B doesn't change the range. What it does do for our conclusion, we can say B stretches and shrinks the graph horizontally. The number B, so the number, sorry, I'll give you, you can pause that if you want to write that quick. The number B, so the B value itself, is the frequency. It gives you the number of cycles. So B is equal to frequency, which is number of cycles between 0 and 2 pi. And if you take 2 pi and divide it by that frequency, or divide it by B, that will give you the period. And I want you to get used to thinking that period means the length of one cycle. Okay? All right, now for each of the following functions, I want you to just looking at the equation, so we don't need the graph at all, on the amplitude, frequency, period, and range. Okay, so first one. If I've got 6 sine of 4x, what's the amplitude? 6, right. Technically, amplitude is always absolute value of A. The A value is 6. So this is the absolute value of 6, which is just 6. Let's go across and do all of them at once. What would be the amplitude on B? It'd be the absolute value of 8, which is just 8. And C? Remember, absolute value of -12. So the answer to amplitude should always be a positive number, just 12. Next is frequency. Frequency means the number of cycles between 0 and 2 pi, but if I'm looking for frequency, and I just have an equation, we just want the B value, the number that's multiplied by x. So it's 4 for this one. What is it for the second graph? Yep, it's weird, but it's pi over 3. Pi over 3 is still a number. And for the last one, 2/3. So that means there's 2/3 of a cycle between 0 and 2 pi. This technically means there's pi over 3 of a cycle, so a decimal of a cycle. Okay, so now period. How do you find period always? It's 2 pi divided by B. So this would be 2 pi divided by 4. So this would have a period of pi over 2. So the length of one cycle would be pi over 2. Just like that purple graph we drew up at the top. This one, again, looks kind of weird. You do 2 pi divided by pi over 3. Complex fractions, you multiply top and bottom by 3. So this would be 6 pi over pi. The pi's cancel. This has a length of 6. So this cycle happens every 6 units. And the last one over here, the period would be 2 pi divided by 2/3. You multiply top and bottom by 3. So now it's 6 pi over 2. So it would have a period of 3 pi. Take a distance of 3 pi to make one full cycle. And then lastly, the range. So far, what's the only thing that affected the range? The A value. So this one, instead of having a range of -1 to 1, is going to go from -6 to 6. The second one's range will be -8 to 8. And the last one's range will be -12 to 12. You always do low to high, so even if it's reflected, the -1 comes first for the range. Okay, so picking out those values from an equation, hopefully pretty easy. There will be more that affects the range, but we'll look at that tomorrow. Okay, last page. Let's do some application stuff. So now I want to go backwards. I'm giving you graphs, and I want to come up with the equation. So, a few things you have to think about. Look at this first graph. Where does it start? So when I mean start, look at the beginning of a cycle. So here's one cycle. I go up, I come down, and I come back. That's one cycle. So I would say this cycle starts at 0. So if a cycle starts in the middle, so starts at 0 or starts at the midline, is that sine or cosine? It's sine. And furthermore, is it positive sine or negative sine? It's positive sine because the beginning of the cycle goes up first. Okay, so it's sine. What's the amplitude? There's a couple ways to look at it. Max minus min divided by 2. 3 minus -3 divided by 2 is 6 over 2. So the amplitude is 3. Now you can also look from that midline. It's going up 3 and down 3. That's why the amplitude is 3. It's not reflected. So this means my A value is going to be 3. For the frequency, also kind of two ways to do it. If you can see 0 to 2 pi, here's 0 to 2 pi. Frequency is number of cycles. So how many cycles happen between 0 and 2 pi? There's 2 of them. There's 1, there's 2. So the frequency is 2, which means D is 2. Now another way to find frequency would be to use period. The length of one cycle, remember period is 2 pi over b. The length of one cycle is pi. So the period here is pi. So if I say pi equals 2 pi over b, I can cross multiply. I would get pi b equals 2 pi. And when you divide by pi, you get the b equals 2. So if you can see 0 to 2 pi and can tell the frequency, that's probably the easiest way to get it. But if you can just tell what the length of a cycle is and you only can get the period, you can solve it that way also. So put it all together. That first equation is going to be y equals, we said a was 3, so 3 sine, because it started at 0, of b was 2, 2x. And today all we're dealing with is amplitude and frequency, so you really have to worry about the a and the b value. Okay, let's do this other one over here. This one starts above the midline. So is it sine or cosine? It's cosine. The midline obviously splits it in half. It's going to be at 0 for today. So since it starts above the midline, it's got to be a cosine graph. And it's a positive cosine as opposed to a negative cosine because it starts up instead of down. If it started down, it would be negative cosine. What's the amplitude? Well, the max is 3 minus the min of -3 divided by 2. It's going to be 3 again. 6 divided by 2, or 3. And you can see that today because it starts 3 above the midline and goes 3 below the midline. So either way, I know amplitude is 3. What would the frequency be? How many cycles between 0 and 2 pi? Well, that's only half a cycle of cosine. Cosine keeps going like that. So the frequency is 1/2. Or you could say the full period would go to 4 pi. So you could say the full cycle is 4 pi equals 2 pi over b. So when you cross multiply, you'd get 4 pi b equals 2 pi. Divide by 4 pi. You're going to get b is 1/2. So here my equation would be y equals 3 cosine of 1/2 x. Okay, so when you're finding equations, for now at least, you're basically going to be looking for what's the amplitude, what's the frequency, and is it sine or cosine. But watch out for if it reflects too. If this is started at -3, we need a negative out front. Same with if this went down first, you need a negative out front. Okay. Almost done. Number 5. Sketch the function y equals -2 sine of 4x on the grid below for one full cycle. Label your scale on your x-axis. Okay, what's the word we've been using that means one full cycle? Period. So we got to figure out what is one full cycle. So period, how do I find that? From an equation, it's 2 pi over b. So this would be 2 pi over, what's b? 4. So pi over 2. So that's going to tell me how to set up this grid. So since I want it for one full cycle, when I graph, I normally go 0, I'm going to skip pi over 2, pi, 3 pi over 2, and 2 pi. And that's one cycle. But here I want one cycle to be pi over 2. So instead of labeling this last spot 2 pi, just label it pi over 2. Then what would this middle spot be? Well, what's half of pi over 2? Half of a half is a quarter. Think cents. Is that 50 cents? Quarter? So this would be pi over 4. But it doesn't really matter if you don't want to label that middle section, as long as you have these spaced out, with the ending being the period value, that's labeled okay. And let's just go by ones here. So this is 1, 2, 3, 4, -1, -2, -3, -4. Okay, so I've got my graph labeled based off of the one full cycle. Now what's the amplitude here? It's not -2, it's +2, because amplitude's always absolute value. So think about what your parent graph looks like. Normally, I have pi over 2 pi, 3 pi over 2, 2 pi. Where does sine normally start? 0. And then normally it goes up, back to 0, down, back to 0. So that's, you can think of that as the parent graph. That's your regular sine graph. But since there's a negative here, what else is going to have to happen? I'm going to have to reflect. And when I notice a negative in a graph, I usually circle it, just write myself a note to reflect it. So I'm still going to start at 0, because it's a sine graph. Instead of going up, and how far would I go up? Well, since the amplitude is 2, I would go up to 2. I'm going to start by going down first. So down to -2, back to 0, then up to 2, and end at 0. So there's your graph between 0 and pi over 2. And you can always check it. Just set up your window. If I want to do -2 sine of 4x, I would just set my window to be the picture I have here. So my x min is 0. My x max now is only pi over 2. Just going to leave the x scale. Y min, I still went -4 to 4. And when you hit graph, you should see this exact one cycle. If you do, you know you got it right. There it is. So on the homework tonight, I'm not going to be able to show you what the sketches look like on the answer key. So use your graphing calculator once you draw yours and check to see if it's right. If it's anything other than that one cycle, you know you did something wrong. Okay, last one. The heights of the tides can be described using a sinusoidal model. That says sinusoidal. That just means it's a sine graph. sine or cosine. So sinusoidal means it has that shape. Sine and cosine have similar shapes in this form. If high tides are separated by 24 hours, what would be the value of B in the equation? Okay, so think about what they're telling you here. They're telling you it's a cosine graph. And again, sinusoidal describes sine and cosine. It's a little misleading. So it's a cosine graph. Let's say this up here is high tide. I don't know how high that is, but whatever. This down here is low tide. And it's a cosine graph. So it starts up, goes down to low tide, comes back up. But I know that one cycle from high tide to high tide is 24 hours. So in other words, the length of one cycle is 24 hours. So what are they telling you about? If they're telling the high tides are separated, if they're telling you the length of a cycle is 24, what means the length of a cycle? Period. And they want you to find the value of B. Well, that's pretty easy then. If you analyze this and realize that period is 2 pi over B, what's this period equal to? 24 equals 2 pi over B. So cross multiply. 24B equals 2 pi. Divide by 24. What's B? Pi over 12. Okay, and that's it. All right, so I think I've given you examples of everything that's in the homework, so give that homework a shot. If you run into trouble, let me know, and I will see you soon. Good luck.